You are welcome to episode 35, Geometry. Today we want to make some proof of circle theorem, in which we all know we have 9 major theorems guiding every shape inscribed or ascribed in a given circle, depending on individual understanding of the theory. But for me, I will arrange it this way. Theorem 1. Angle subtends by an arc at the center of a circle is always twice the angle touching the circumference of that circle. That is, if angle at the center is x, then angle at the center, if it is x, assuming that it is x, and angle touching the circumference is y, we are saying that angle at this center is twice angle at the circumference. How do we now prove this? Assuming we have a transverse line this way, that means this place is a radius. So we have paired this one into 2. So let's assume that this one is y1 and this one is y2. So if this one is y1, since this one is isosceles triangle, this place will also be y1. So addition of y1 with y1 will give us this place. 2 interior is equal to 1 exterior. Likewise here, we can say that y2 here is the same thing as y2 here. But we are now saying that at this end here, this place here, we are saying that exterior to interior, y1 plus y2 equals to, let's assume that it is x1. Then also y2 plus y2 will be equal to, let's assume that it is y1 plus y1, y2 plus y2. We agree that it is x2. So if by virtue of that, since this is our x is x1 plus x2. So therefore, to prove it now, since x1 plus x2 is normal x, then that means 2y1 will be equal to x1 and 2y2 will be equal to x2. If we now pair them together, that means x will now be 2y1 plus 2y2. Don't forget that our y is equal to y1 plus y2. So if that is the case, 2 is common here, then we can now say that x equals to the common 2, that is y1 plus y2. since this one is that, so we can say that this one is 2y. Proved. Proof. So we have shown that x, the center here, is equal to 2y. Let us now go into theorem 2. We say theorem 2, angle formed from the same segment touching the circumference of a circle are always equal to each other. What are we saying? We are saying that if this angle is x and this angle is x, is y, we say x is equal to y. So if x is equal to y, let's prove it, whether x will be y. From here, if we produce a line to this side and also produce a line to this side, these are radius. Quite alright. This is the segment. So since this is radius, this will be angle at the center. According to theorem 1, angle at the center, let's call it theta, is twice angle at the circumference. So that means we have twice angle at the circumference. So if the angle at the circumference is y, then theta will be equal to 2y. If the angle at this circumference is y, theta will be 2y. If we look at it here also, this side, angle at the center again is equal to twice angle at the circumference. That means theta again is equal to 2x, if that place is that. So since theta is equal to theta, therefore 2y will be equal to 2x. 2 we cancel 2, then we can say that x equals to y. Proof. So we can now see that theorem 1 and 2 work hand in hand. Theorem 2 says that angle formed from the same segment touching the circumference are always equal to each other. By next episode, when we shall meet, we shall look at other theorem. Thank you. You can help us subscribe and share the video to as many as possible. Thank you.